Hi everyone, my name is Laura, and following on from childhood nutrition, I'm going to talk about adolescent nutrition. So, adolescence is technically between the ages of 10 and 19. At this age, there are many biological, psychological, and cognitive changes that are occurring, all of which impact on nutrition requirements. However, an increasing desire for independence also influences individual dietary choices. These factors, coupled, have therefore led to a large proportion of adolescents not meeting their nutritional requirements and putting them at risk of future health implications. Given the limited data available regarding adolescent dietary intake in Australia, many of my statistics regarding intake of specific food groups was obtained from the Australian Institute of Health and Welfare's report, Profile of Nutritional Status of Children and Adolescents. This report was published in 2007 and contains statistics from the 2004-2005 National Health Survey and the 1995 Nutrition Survey. To build on from this, I used more recent information about the intake of specific nutrients from the Australian Bureau of Statistics report on the 2011 to 2012 Australian Health Survey of usual nutrient intakes. This report provided statistics about adolescent micro and macronutrient intake in comparison to the current nutrient reference values, allowing me to investigate the potential implications of this. While estimated energy requirements are largely varied between age and gender, a significant proportion of adolescents are not meeting the specific recommended requirements. When comparing to the appropriate macronutrient distribution range, half of the adolescent population are consuming less than the recommended proportion of carbohydrates. Since carbohydrates provide an immediate source of glucose to the cells, this may impact on cognitive functioning, physical performance, and subsequent growth patterns during puberty. A further 30% are not meeting the recommended protein requirements, which may impact on the ability to form and maintain lean body mass. In turn, this can result in reductions in linear growth, delays in sexual maturation, and reduced lean body mass. Meanwhile, 20% of adolescents are consuming fat in excess of the upper limit. While fat is important in providing essential fatty acids for growth and development and to allow absorption of fat-soluble vitamins, such an excess may contribute to poor weight maintenance. Specifically, of this fat intake, the average adolescent is consuming 14% of their energy from saturated fats. Saturated fats are effective in elevating low-density lipoproteins, thereby increasing the risk of chronic disease development. Major sources of saturated fats are discretionary foods such as chips, chocolate, and takeaway. An increased freedom of dietary choice in this age group has resulted in the high consumption of such foods and has similarly contributed to a high sodium intake. Approximately 76% of adolescent males and 42% of females exceed the upper limit of sodium. Essentially, such an excess can contribute to high blood pressure and excessive energy intake. This acts as a risk factor for a range of conditions including CHD and kidney disease. Adequate intake of vitamins and minerals is essential for cell and muscle functioning, bone formation, hormone production, and fluid balance. While each food group contributes to a range of these, we will focus on the main vitamins and minerals each food group contains. The vast majority of adolescents are achieving the recommended 5 to 7 serves of cereal products per day. Fortification of wheat flour with folate and thiamine is mandatory for bread making in Australia, and iodized salt must be used as a preference over non-iodized salt. This fortification has therefore contributed to the relatively low percentages of inadequacy seen for male and female adolescents, as seen on the screen. Despite males consuming high proportions of cereal products, their estimated average requirement for zinc is almost double that of females. Additionally, zinc extraction is lower in processed cereals. Since the data does not acknowledge the proportion of processed and whole grain cereals consumed, a low intake of whole grain cereals may account for the lack of zinc intake seen in males and females. Zinc deficiency can essentially retard growth, impair cognitive development, and delay sexual maturation. The recommended 2.5 serves of meat, poultry, fish, and eggs and plant-based alternatives have most commonly been met by males, with fewer females reaching such targets. This has led to a high proportion of females obtaining inadequate intakes of iron, zinc, B6, and B12, as shown on the screen. The prevalence of iron deficiency in adolescents can contribute to fatigue, impaired cognitive functions, impaired growth, and disruptions to the menstrual cycle. Inadequate consumption of B6 can impair metabolism of amino acids, thus contributing to poor growth and development during puberty. Similarly, inadequate B12 intake can lead to poor brain and nervous system functioning, as well as a reduced DNA and blood synthesis. Many adolescents do not meet the recommended 3.5 serves of dairy per day. This is evident when we consider that 90% of females and 71% of male adolescents do not meet the RDI for calcium. Furthermore, 17% of females and 5% of males have inadequate phosphorus intake. Given that calcium and phosphorus are important for the maintenance of bones and teeth, failure to attain peak bone mass can lead to osteoporosis and other bone-related conditions later in life. Approximately 75% of both males and female adolescents are not meeting the recommended 5 servings of vegetables each day. Ultimately, this has contributed to the 1/3 of adolescents who are not meeting their recommended intake of vitamin A. Vitamin A plays an important role in immune function and vision, as well as assisting in reproduction. Mild deficiencies can increase the risk of delayed growth and bone development. Additionally, 72% of females and 61% of males are not meeting the estimated average requirements of magnesium. This can impact on bone development during adolescence, blood glucose control, and protein production, which are all vital biochemical activities during adolescence. Other nutrients in which poor intake of vegetables impact have already been discussed, which include folate, vitamin C, and fibre. Approximately 3/4 of the adolescent population are not meeting the recommended 2 serves of fruit per day. This has had a significant impact on the adequate consumption of many nutrients which have been previously discussed, which include vitamin A, folate, fibre, and magnesium. Evidently, there are many alarming statistics which need to be addressed in order to prevent the future health implications. Specifically, public health policy should focus on reducing consumption of high sodium and saturated fat discretionary foods, as this is likely to contribute to the coronary heart disease and hypertension. Furthermore, there should be a push for consumption of whole grains over processed grains in order to help adolescents achieve adequate zinc intake for optimal cognitive functioning and physical growth and development. Poor iron, zinc, B6, and B12 due to insufficient meat and meat alternative intake should be corrected in order to prevent anemia in adolescents, as well as combating fatigue and impaired menstruation. Additionally, high intake of calcium is essential to prevent the onset of osteoporosis or other bone-related conditions later in life. Furthermore, inadequate consumption of magnesium and vitamin A may impact on bone development and immune functioning. Therefore, there are many strategies we need to employ in order to encourage the adolescent population to adequately consume each of these macro and micronutrients. If we do not get the adolescent population to do this, there are likely to be further health implications, putting pressure on our healthcare system in the future and increasing the disease burden later in life. Thank you.